Alright, welcome back. So today we are going to be looking at how to name organic halides. But before that, we're just going to have a look at the different families of organic compounds that we can get. Now, from one of our first lessons in organic, we did look at the difference between hydrocarbons and hydrocarbon derivatives. So the organic halides are going to fall underneath the derivative headline or family. And these are molecules that contain carbon, hydrogen, and another type of atom. Now, what are we going to be looking for is these things called functional groups. So this is a characteristic arrangement of atoms or bonds within a molecule that determines the most important chemical or physical property. So organic compounds are classified according to their functional groups, and the functional groups just tell us what family we have. So just by looking at the alkanes, our general formulas, we know we had carbon to carbon single bonds. Right, so for example, we see something like that. We can have butane. Now for an alkene, right, we would have had to have at least one carbon to carbon double bond. So this double bond is the functional group, and an example with that, we get something like propene, and notice that the ending changes. And even with our alkyne, so we have a carbon to carbon triple bond. And example of that would be something like propine. So we've seen all these here, and then of course our last ones, our aromatics. We've seen something like that, so our benzene, or like that, it doesn't matter. And our example, well, obviously, benzene. So those were all of our just normal hydrocarbons. Now next we're going to get into our organic halides. And of course our other types of families here, we have organic halides, alcohols, carboxylic acids, and esters. So what an organic halide is we are going to have, the general formula looks like this, where R is equal to a hydrocarbon and X is equal to a halogen. So for example, if we had something like this. Alright, so we can tell our hydrocarbon right here is we have 1, 2, 3 carbons, so we have a propane, and then we have a bromine sticking off here. Alright, so for the names, we're not going to worry about the names right yet, just going to give you examples. Now for our alcohol, we're going to see something like this. So same thing, R is equal to hydrocarbon, could be any hydrocarbon. In this case right here, OH. Now normally, when we had our acid-base chemistry, it was OH minus is a hydroxide ion, but when we have it covalently bonded to a carbon like this is called hydroxyl. So an example of what we can have, you'll see something like this. So same thing, we can have our hydrocarbons. In this case right here, we have a propane with a hydroxyl. So we're going to get into how we can name these eventually. Now for our carboxylic acids, one thing we're going to see, same thing, we'll see a hydrocarbon group, but then right at the end, we're going to see C, double bond O, and OH. So what we have right here, I'm not going to write it this again, R is still going to be our hydrocarbon, but we do have a special name for this entire functional group right here. So this whole thing right here, so C double bond OH is called a carboxyl group. And for example, if we see something that looks like this, so we can have right a carboxylic acid that'll look something like this, where you see that functional group. Now I drew in the carbon here. We'll look at examples later where you don't really need to draw them in because it's line formula. I just want you to see the hydrocarbon or that carbon inside of that functional group. Finally, our esters, we will see a hydrocarbon group. We'll see C double bond O, O, and then we will have a different hydrocarbon. So that's just going to represent R with the little dot up above there to indicate that it is a different hydrocarbon group. And of course, this needs a name. So what you're going to look for is this group of molecules right here. And this is called the ester group. And an example, if we see an ester, we can have line formula. Something that looks like this, where you can see that ester group is kind of sandwiched in between our two hydrocarbon chains here. So of course we will kind of get into naming these eventually, but just for today, I want to stick with just the organic halides, get those out of the way, and then the next lesson we'll focus on the alcohols, carboxylic acids, and esters. So for our organic halides, we'll see these right here. So just like on the previous page here where we had R bonded to X, where R represents any hydrocarbon chain and X just represents a halogen. So with these right here, what we're doing is just we're replacing a hydrogen with a halogen. Now, one thing, especially when it gets to the naming, treat halogens like branches. So that means there's nothing really special about them. Is that we're going to treat them like branches. So when we're trying to figure out carbon number 1, if it's just an alkane, carbon 1 is always closest to our first branch, so we're just going to treat them like a normal branch. However, when we do name them inside of our compound, if we have a fluorine, we'll call that a fluoro branch. Chlorine is a chloro branch. Bromine bonded will be a bromo branch. And iodine bonded will be an iodo branch. So let's look at actually just tying this in, and this is why the naming, we don't see an elaborate list of how to name stuff, because we just treat the halogen as a branch using the prefixes, and therefore if this is just attached to an alkane or an alkene or an alkyne, you just had to remember how to name those. So our first example we have right here. So just like before, whenever we start naming a hydrocarbon, we first need to find our longest continuous carbon chain, right? So of course, you can probably see that our longest continuous carbon chain is going to go basically along here, just like that. So almost right up through the middle of this compound. Now when we start trying to number our first carbon, because after we find our longest continuous carbon chain, we have to number them. We always start carbon 1 because this is an alkane, is going to be closest to our first branch. So if we start down here, this will be carbon 1, 2, 3. So our first branch will have carbon 3 if we decide to start down at the bottom. But if we start from the top there and label this 1, 2, we'll notice our first branch, actually 2 branches have carbon 2. So this gives us lower numbers, so therefore carbon 1 is going to have to stay out there. And we have the rest of our carbons numbered like this. So we have 5 carbons. So our parent is equal to pentane. And now we just need to name our branches. So this one right here, right, just CH3, so this is a methyl branch. But now just from up above we have these halogens right here, and this is bromine, so its branch name is bromo. Just like that. So we have our parent chain, which is pentane. We have all of our branches listed. So we got methyl and 2 bromos. So putting together a name is just like stuff that we've done before. So we have to list them in alphabetical order. And of course, making sure we put in the position, everything like that. So B comes before M in the alphabet. So I'm going to have to label my bromines first. So we have our bromo branch off carbon 2 and 3. So the name is going to start with 2, 3. There's 2 of them. So we go dibromo. Then we name our methyl, so that's on carbon 2. And once all the branches are named, we name our parent chain, which is pentane. So the name for this one right here is 2,3-dibromo-3-methylpentane. And that's it. So just like the other one, I just want you to pause this video and try naming the second one on your own. But I'm just going to go over how to name it in 3 seconds. Alright, so for this one here, the longest continuous carbon chain, we can go this way if we want. Now you could have just went straight across the middle if you want. You would still get the same number. I'm just doing like this just to kind of show that you can potentially go down. Now, for this one right here, we'll notice that if we start numbering, so carbon 1 is right here, and we go 2, 3, 4, 5, and 6, we're going to get branches off carbon 2 and 5. So I'm just going to put it the other way, just to make sure I have lowest numbers. So if we start down here and we go 1, 2, 3, 4, 5, 6. Okay, so we still get branches off carbon 2 and 6. So just, you have to remember that whenever you're kind of stuck like this, if you do come across where you get branches on the same positions as possible, the one that is going to take priority is going to come, the one that's going to get labeled first in the alphabet. So because we know chlorine is a chloro branch, where CH3 is a methyl, chlorine is going to get listed first when we actually name this one because C comes before N. So because of that, carbon 1 is going to be closest to the chlorine. So then when we name this one, we get a name of 2-chloro 5-methyl hexane. That's that one. So same thing as before. I don't want you guys to draw this on your own. I'm going to be putting the answers up very shortly, but we have 2,2,5-tribromo 5-methylhexane and 1,4-dibromobenzene. All right, so I'm going to put the answers up in 3 seconds. And these are our answers. So we got our 2,2,5-tribromo 5-methylhexane right here, and our 1,4-dibromobenzene here. So hopefully you have something that looks similar to those. Now we have 2 more on this page right here, so you will notice that we are going to jump into a little different where we have our propene. So we have an alkene right here, and then of course we also have a 1,iodo-3-methylpentuene. So same thing, try to draw these on your own, and the answers are going to go up in 3 seconds. And we have our answers right here. So I did kind of put in which carbons are labeled 1, 2, and 3. And when you're drawing these here, specifically line formula, just be careful because this line right here is a bond and at the end is the iodine. There's not a carbon right here, right? So that's why carbon 1 is right here. And then we go 2, 3, 4, 5. So that's our pentene. And then of course the double bond on carbon 2 here. And we have our 1-iodo-3-methylpentuene. Then of course our other one, 1,2-dibromo propene. The reason that there's no prop-1ene there is because there's only one way to draw propene. And that's that one looks like. So those are our organic halides. So continue working in your workbooks. And next lesson, we're going to be looking at alcohols, carboxylic acids, and esters. See you guys then.